Hello friends, welcome. Let's have a look at this 10th grade mensuration problem. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. This bucket is emptied out on the ground and a conical heap is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So let's try to understand the problem and see what formula we have to use here. A cylindrical bucket, and so I have a cylinder. Let me write it down here. So cylindrical bucket, height is given as 32 centimeters. Radius is 18 centimeter. I will write it down. Radius is 18 centimeter. Is filled with sand. The bucket is emptied out on the ground. So nothing but the cylinder is filled with sand and again it is emptied out on the ground. So you can see that if you fill the cylinder with the sand, we are talking about the volume of the cylinder. So we are talking about now volume of the cylinder. So the sand is emptied out on the ground and a conical heap is formed. So we have now converted into its now the volume should be equal to the volume of the cone. What are the details we know about the cone? We know cone height, let us say HC, equal to 24 centimeter. We have to find out what is RC and also what is slant height of the conical heap. Now we just learned that the volume is same in both cases, so I can equate the volume. Now what's the volume formula for cylinder? Cylinder volume is pi r square, that's a base area circle multiplied with h, pi r square h. Now what is the formula for volume of the cone? That's equal to 1/3 into pi into r square into h. Now let's equate these volumes. We will say volume of cylinder is equal to volume of cone. By that we should be able to get the calculation. So pi into r square, r is 18 square into h, that's equal to 32, equal to 1/3 into pi into RC. I don't know, I have to find it out. What is HC? HC is 24. Now we have to simplify this. Pi will cancel it out. Let us say RC square equal to, if I take 3 there, it will become 96 into 18 square plus by 96 into 18 square divided by 1/3 into pi r square into h. If we simplify that, we will have 24 will go 4 times. 4 into 18 square is 1296. 4 into 18, 18s are 324, so I'll have 1296. We are talking about cm, so that is 1296 cm, 1296, or can I say r equal to 36 centimeter. So we got r equal to 36. Now can you find out the slant height? If you know the RC, you know the HC, can you find out LC? How to do that? We have a simple formula for that. What is the formula? The formula is, let me write it down here. LC equal to square root of RC square plus HC square. Because how the cone looks like? The cone will be like that. And you have, this is height and this is radius, height, and this is slant height. You can see you have a right circular cone, so there is a 90 degrees angle. Hypotenuse is nothing but square root of sum of squares of the remaining two sides. So L equal to square root of RC square plus HC square. You can substitute the values of 24 and 36 and you can find out that value. The value will be equal to LC will be equal to 12 into root 13. Just check whether you got that by substituting 24 square plus 36 square, and you simplify that whether you got 12 root 13 or not. So let me summarize this before we close this problem. It's a very simple example. We have been given that a cylindrical bucket 32 centimeter high and is of radius of base 18 centimeter is filled with sand. Whenever I say filled with sand, I am talking about the volume. Now this sand is emptied and a conical heap is formed. That means the cylinder is now converted into cone, but the volume will be the same because the sand quantity is the same. So equate both the volumes, then we can easily find out the radius of the cone. Once we know the radius of the cone, finding out the slant height is directly using the formula slant height equal to square root of radius square plus height of the cone. So in the next session we will do one more interesting example of 10th grade mensuration.